Hey, it's the Math Guy Steve. All right, so this time we're reviewing for our Math 1610 final exam. Let's get to it. So the first example here says, okay, for the given function f of x equals 2x plus 4, perform the following, right? So find these things, right? So this is a linear function, meaning the domain here would just be all real numbers, okay? Negative infinity to infinity. The range is similar, okay? Because it's linear, the range is also all real numbers, negative infinity to infinity. To find the x-intercept, we set the function equal to 0 and solve for x, right? So here we 0 equals 2x plus 4, and I'll solve for x, right? So subtract 4, we get negative 4 equals 2x, divided by 2x equals negative 2. Easy stuff. So that would be nice. It says write it as an ordered pair. I'm sorry. Yeah, write them as an ordered pair, right? So we would say negative 2 comma 0. To find the y-intercept, we plug in 0 for x. In other words, f of 0. And so that would be 2 times 0 plus 4. And so we get, that's just 4. So our y-intercept would be the coordinates 0, 4. We need to find some more things. It says determine the asymptotes if applicable. For linear functions, there are no asymptotes. Okay, so there is no horizontal or vertical asymptotes for linear functions. Determine the intervals over which the function is increasing. This one has a positive slope, so this one's increasing over its entire domain, meaning over all the real numbers. So the function is an interval notation. The function is increasing from negative infinity to infinity. Whereas the function decreasing, again, because we have a positive slope, this one isn't decreasing at all, so it's never decreasing. And then which graph? Of course, again, since it's linear, we know it's a line, and it has a positive slope, so it would be this graph. Example 2 is similar, except now we have a quadratic, right? That squared gives it away. It's a quadratic, right? So, right, the domain for quadratic functions, the domain is still all real numbers. Whereas the range, not so much, right? So this one here, it's a quadratic shifted to the left 3 and down 1. And so this is what we call vertex form. That's f of x equals a times x minus h squared plus k, where hk is the vertex, right? So here the vertex would be negative 3, negative 1. Okay, so negative 3, negative 1. So here is our vertex, and again, it's opening up because that a is positive. The a is positive. So the range, that helps us with the range is from negative 1 to infinity. Okay, with a bracket on negative 1. Find the x and y intercepts. So to find the x intercepts, again, set the function equal to 0. So 0 equals x plus 3 squared minus 1. And solve for x, right? Adding 1, we get 1 equals x plus 3 squared. Taking the square root, don't forget the plus or minus, right? So it would be plus or minus 1 equals x plus 3. And so we can split that into two separate scenarios, or scenarios, where we get positive 1 equals x plus 3, or negative 1 equals x plus 3. So solving those separately, subtract 3, we get negative 2 is x. So there's one of our x-intercepts. And here, subtracting 3, we get negative 4 equals x. Every other x-intercept. And so here we put those as negative 2, 0, and negative 4, 0, with a comma in between, okay? To find the y-intercepts, we plug in 0 for x, right? So f of 0 would be 0 plus 3 squared minus 1, which is 9 minus 1, so 8. So, okay, so our y-intercept would be 0, 8. It says determine the asymptotes if applicable, again, or applicable, I guess. There are no asymptotes for quadratic functions either, right? So there's no horizontal or vertical asymptotes. 6 says determine the intervals over which the function is increasing, right? So again, because our graph looks like this, right? Decreasing, and then it starts to increase. So at this x value is where it starts to increase, and that's at the x value negative 3. Okay, so if we look at our graph from up here, the x value negative 3. So again, with those increasing and decreasing, we're talking about over which x values, right? So it's increasing from negative 3 to infinity, and it's decreasing from negative infinity to negative 3. Okay. And then lastly, we get to pick a graph, and of course, this is the one here, right? Then we get to graphs like this. So doing the same thing, find the domain of the function, right? This is a cube roots graph, which is that, remember that snake figure that we had, right? It was like this, except this one shifted to the right 2 units. Okay, so it'd be, instead of going through 0, 0, this would go through 2, 0, looking like this. So what's the domain of the function? For those cube root graphs, the domain is all real numbers, and the range is as well, all real numbers. What's the x-intercept? Again, how do you find the x-intercept? Set the function equal to 0. So 0 equals is just the cube root of x minus 2. So cubing both sides, we get 0 equals x minus 2. So x equals 2. And so our x-intercept is 2, 0. Okay. The y-intercept, we plug in 0, right? So f of 0, which is the cube root of 0 minus 2. In other words, the cube root of negative 2. So that would be our y-intercept. I think Alex wants you to approximate this value by putting in your calculator. So I got about negative 1.26. Okay. So 0 comma negative 1.26 approximately. And determine asymptotes, if any. Again, for cube root graphs, there's no asymptotes either. So no horizontal or vertical asymptotes. Determine where the function is increasing. This one's always increasing, right? It's slowly getting bigger each time. So it's increasing from negative infinity to infinity. And this one's not decreasing at all, so never decreasing. And then lastly, our graph, which we said it looks like this, right? All right, the fourth one here. Now, we get to use rational functions. So if we want to find the domain of a rational function, remember we said rule number one, we're not allowed to divide by 0, right? So we know this denominator cannot be 0, meaning x plus 7 cannot equal 0, so x cannot equal -7. So how to find the domain, it tells us to write an integral notation. We'd say, well, all the real numbers except for -7. So -infinity to -7, parentheses, union, parentheses, -7 to infinity, okay? Meaning, if you recall, that means that we have a asymptote at -7, right? So our graph will look something like this, right? 1, 2, 3, 4, 5, 6, 7. We have this vertical asymptote here, x equals -7. And then we said to find the horizontal or oblique asymptotes, we look at the powers, right? Look at the degrees. Meaning, if the degree of the numerator is smaller than the degree of the denominator, then we know that there's a horizontal asymptote at y equals 0. And then how do we find if that asymptote is crossed or touched? We set the function equal to that and see if it's solvable, right? So like here, if I set it equal to 0, 0 equals 7 over x plus 7, but then multiplying by x plus 7 on both sides, we get 0 equals 7. And this just isn't true. Meaning there's no values where that graph is crossing the horizontal, or touches the horizontal or oblique asymptote. Here we don't have the horizontal asymptote. So that's our domain. To find the range, again, well, that would give us, if we knew the shape of the graph, that helps, right? So we know the range here is, we know we have this boomerang here and then this boomerang here. How do we find that? Is we can also find just one other value. Like if we're plugging, find the y-intercept, right? By plugging in 0 into the function. So p of 0, which we have to do later. We get 7 over 0 plus 7, which is 7 over 7, so 1. So 0, 1. And now we use the multiplicities, right? If this one's up top, this one has to be down below. Okay. So the range, we know, is from -infinity to 0, and then union 0 to infinity because of that horizontal asymptote. X-intercepts, again, the horizontal asymptote is at the x-axis, so it never crosses or touches the x-axis. So we'd say none. Whereas the y-intercept we just found, right? I plugged in 0 and we got 1, so the y-intercept would be 0, 1. What asymptotes we just pointed out, right? So our horizontal asymptote is at y equals 0. Our vertical asymptote is at x equals -7. Okay. Determine where the function is increasing. So this one's always decreasing, right? Now, it's decreasing over its entire domain. But see, it's decreasing here. And then here it's also decreasing, right? So we have to say, okay, well, over its domain, meaning where is it? It's not increasing at all, never increasing. But it's decreasing from -infinity to -7. And then also from -7 to infinity. Okay, so on both of its pieces are boomerangs. And so which graph is it? I believe it's this one here, D, right? It's D, sorry, no, not D, A, it's A. Right, it's decreasing here and then decreasing here. Yep. We say A. All of them were A so far. Okay, then we get to ones like this. Okay, so this one here is a little bit different, right? And that is, okay, first, we know the domain, same thing, right? X minus 3 cannot equal 0, x cannot equal 3. Makes sense. So that's where our vertical asymptote is. So our vertical asymptote, the x equals 3. But then the horizontal or oblique asymptote, look at the degrees, the powers. And here, the degrees match, right? They're 1 and 1. And so we say, well, if they match, then we divide the coefficients in front of those numbers. In other words, -3 divided by 1 is -3. So we have a horizontal asymptote, but this time it's at y equals -3. Then we want to see if that is ever crossed or touched by setting the function equal to that number. So -3 equals -3x over x minus 3. Multiplying by x minus 3, we get -3x plus 9 equals -3x. But then adding 3x to both sides, we get 9 equals 0. Which just isn't true. So our horizontal asymptote is not crossed this time, okay, or touched. But that does give us a kind of a shape, right? So we said, okay, well, to find out where the boomerangs are, or where the pieces are, we said, let's find some other points, right? So like x-intercept. Find the x-intercept, we set the function equal to 0, right? So 0 equals -3x over x minus 3. Also by x minus 3, we get 0 equals -3x. So x equals 0. So x-intercept is 0, which of course would be our y-intercept as well, plugging in 0. So we know, since we have this points right here above, that whole piece has to be above, which means by our multiplicities, the multiplicity on 3 is just 1, and so this one has to be below, because remember, odd, opposite, right? So this helps us to answer the rest of our questions, right? So to find the range, we see, okay, it goes from -infinity to -3, and then -3 on, -infinity to -3, and then from -3 to infinity. The x-intercept we just found was 0, 0. The y-intercept is also 0, 0. Right? If I plug in 0. Our horizontal asymptote, we got y equals -3. Our vertical asymptote, we got x equals 3. Where is this function increasing and decreasing? So notice for this one, it's increasing here and increasing here. So it's increasing over its entire domain, meaning we'd say it's increasing from negative infinity to 3, and then also from 3 to infinity. And this one's not decreasing at all. Right? It's not decreasing at all. And then lastly, we need to find the graph. I think it's B here. Yeah, I think it's B. Yeah, B. B our graph. All right, we're moving. 6 here says, okay, what about this function? So this function is also a quadratic, right? So to find the domain, we know for a quadratic, well, to graph the quadratic function, we probably should find the vertex. To find the vertex, remember we had a formula. If it's not in vertex form, if it's in this form, this is called standard form or expanded form, I guess. We'd say the formula is x equals negative b over 2a, right? Remember we said there's an easy way to remember that. It's a part of the quadratic formula, right? So here we would say that's negative 6 over 2 times 1. In other words, 6 over 2, which is 3. Then to find the y-coordinate of the vertex, just plug that back in, right? M of 3, which is 3 squared minus 6 times 3 plus 9. So 9 minus 18 plus 9, which is 0. So 3, 0 is our vertex, okay? 3, 0 is our vertex here. It opens up. We know it opens up, right? Because this a is positive. And so it looks something like this. Now to find a y-intercept, we see our x-intercept is the vertex this time. To find the y-intercept, we plug in 0, right? So M of 0, which is 0 squared minus 6 times 0 plus 9, so 9. So it crosses the y-axis at 0, 9. So that helps us to answer the questions, right? To find the domain, it's all real numbers for all quadratics. But the range here goes from, the lowest it goes is 0, right? So 0 to infinity. Put a bracket on 0. X-intercept we just found was 3, 0. The y-intercept we just found was 0, 9. What else? There are no asymptotes for quadratic graphs, right? So there's no horizontal or vertical asymptotes or oblique asymptotes, slant asymptotes. Where's this function increasing? So notice it's decreasing, and then at this x value it starts to increase. So it's decreasing, it's increasing from 3 to infinity. It's decreasing from negative infinity to 3. And which graph is it? It's this parabola. Okay, we got more. So this is an absolute value graph. My absolute value is the V-shaped graph, right? So it's shifted to the right 5 and down 1. And so it should look something like this, right? To the right 5 and down 1. So it makes this shape here, this V shape. So that helps us with the domain and range. To find the x-intercept, we set the function equal to 0. So the x-intercept, we'd say, okay, 0 equals absolute value of x minus 5 minus 1. If I add 1, we get 1 equals absolute value of x minus 5. But then absolute value just says, okay, whatever's on the inside of the absolute value is the positive or negative version of it. Meaning, I can split this up into 2 separate cases. X minus 5 equals 1. And then negative of x minus 5 equals 1. And solve these separately. So here if I add 5, we get x equals 6. Here if I divide by negative 1, we get x minus 5 equals negative 1. Adding 5, we get x equals 4. So those would be my x-intercepts, is 4 and 6. Okay, which, I mean, kind of, from my graph, kind of makes it, I mean, it looks kind of like it. To find the y-intercept, we plug in 0, right? So the y-intercept, we'd say k of 0, which is absolute value of 0 minus 5 minus 1, which is 5 minus 1, so 4. Okay, so that would be our y-intercept. We're across the y-axis at 4. So here the domain for absolute value graphs is all real numbers. Okay. The range, we see it goes from negative 1 on up, right? So negative 1 to infinity. The bracket on negative 1 to infinity. X-intercept we just found was 4, 0, and 6, 0. The y-intercept we just found was 4, 0, 4. What else? There are no asymptotes for these absolute value graphs. Where's the function increasing and decreasing, right? So it's decreasing up and down. So where's the function increasing and decreasing? Okay, we see first the function's decreasing and then starts to increase when it gets to the x value 5, right? And so it's increasing from 5 to infinity. It's increasing from 5 to infinity. It's decreasing from negative infinity to 5. Okay. And lastly, what graph? Should be this V shape shifted to the right 5 down 1, right? So A. And let's see what else. Then we get to graphs like this, the square root graph, right? So the square root graph of 6 minus x. Remember, the square root graph is the half parabola turned sideways, right? And so what this negative on the inside does is reflect it. It's a negative on the x, or it's reflected about the y-axis. And then this 6 shifts it up 6. Shifts it to the right 6. So it would be this graph here, okay? So C here. So knowing the shape of the graph kind of helps us out in knowing a little bit about what's going on, right? So if that's our shape of our graph, then what's the domain? Well, we know it goes from negative infinity to 6, okay? Then what's the range there? Again, if that was the shape of our graph, if we go back to the graph here, you can see our range is just from, it's just shifted to the right 6, so it's from 0 to infinity. And the x and y-intercepts, again, to find the x-intercept, set it equal to 0. So 0 equals the square root of 6 minus x. Squaring both sides, we get 0 equals 6 minus x. Then adding x, we get x equals 6. So that would be our x-intercept, is 6, 0. To find the y-intercept, we plug in 0, right? And so f of 0 would be the square root of 6 minus 0, so root 6. Now again, using a calculator to approximate that, The square root of 6 is about 2.45, okay? So 0, comma 2.45 approximately. The asymptotes, there are no asymptotes for these square root graphs. Where's the function increasing versus decreasing, right? So here, this function is continuously decreasing up until we get to the x value 6, then it just stops, right? So it's never increasing, but then it's decreasing from negative infinity up to the x value of 6. And of course, again, that's the graph we have. Then you get to this one's a little bit different, right? So the square root of x minus 6, right? So this one just shifted to the right 6. There's no reflection at all, okay? So this one just shifts to the right 6. So it looks like this, right? So the domain, we'd say from 6 to infinity. The range is from 0 to, with a bracket on 6. Apologies. The range is from 0 to infinity. X-intercepts, we define x-intercepts, set it equal to 0. So 0 equals the square root of x minus 6. Squaring both sides, 0 equals x minus 6. So x equals 6. So that's our x-intercept is 6, 0. To find the y-intercept, we plug in 0 for x. But if you look at our graph, we never touch the y-axis, right? F of 0 will be the square root of 0 minus 6. So that's the square root of negative 6. Which again, if we're talking about real numbers, then there is no y-intercept, so we'd say none. Again, according to our graph, it doesn't touch the y-axis. Determine the asymptotes. Again, there are no asymptotes for these. This one's always increasing, right? And so we'd say over its entire domain, so from 6 to infinity, it's increasing. It's never decreasing. And then, again, the graph we have here is this one here. Then we get to graphs like this. So e to the x plus 3. So that graph is an exponential graph, right? We normally have a horizontal asymptote at y equals 0, but this one shifted up 3, okay, and making this J shape. And so if it shifted up 3, we know a horizontal asymptote is at y equals 3. Normally it would go through 0, 1, but now since it shifted up 3, it goes through 0, 4. And again, it's making this J shape because e is a base bigger than 1. So to write the domain of the function, domain for any exponential function is all real numbers. Whereas the range here, we see it goes from 3 to infinity, okay, from 3 to infinity. Again, it doesn't touch the asymptote, so parentheses on 3. X-intercept, where's across the x-axis, we have to set the function equal to 0. 0 equals e to the x plus 3. Subtracting 3, we get negative 3 equals e to the x. And then we have to ln both sides, but notice that's the ln of something negative, which is not allowed. And so there are no x-intercepts. Again, according to our graph, we kind of see that. So there are none as far as x-intercepts. The y-intercept, we plug in 0 for x, right? So, which I think we just pointed out. You get it? Okay. F of 0 is e to the 0 plus 3, which is just 4. Okay, so 0, 4. Is our y-intercept. As far as asymptotes, there are no vertical asymptotes, but there's a horizontal asymptote. We just pointed it out, right? The vertical asymptote is at y equals 3. Where's the function increasing? This one's always increasing, so over all real numbers, over its entire domain. This one's never decreasing. And then, what graph is it? It looks something like A. A would be the graph. All right, we're moving. 11 here says, for this function, ln of x plus 3, then again, that graph, we have a vertical asymptote this time, and it shifted to the left 3, right? So shift to the left 3, which that would be where our vertical asymptote is. Again, how do we find that? We know the argument has to be positive, right? The inside of the logarithm has to be positive, so x has to be greater than negative 3. So this one, again, because the base is e, which is bigger than 1, this one's an increasing function. So it looks something like this. Okay, we call it an R shape. So the domain is from, as we just pointed out, from negative 3 to infinity. But the range for all log functions is all real numbers. To find the x-intercept, we set it equal to 0. So 0 equals ln of x plus 3. And now we can do our circular motion, right? E to the 0 equals x plus 3, which is 1 equals x plus 3. And so subtracting 3, we get x equals negative 2. So there's our x-intercept. That's where it crosses the x-axis. Is at negative 2, 0. Find our y-intercept, we plug in 0 for x, right? F of 0. So that's ln of 0 plus 3, which is just the ln of 3. We can use our calculator to approximate this. 1.10, yeah, about 1.10. And so we say 0, comma 1.10, okay? There are no horizontal asymptotes for the logarithmic functions, but there is a vertical asymptote. We just said that x equals negative 3. Where's this function increasing versus where's it decreasing? This one's always increasing over its entire domain anyway. So from negative 3 to infinity. Again, because that base is bigger than 1, it's an increasing function. This one's never decreasing. And then which graph? I think it's part C here. Right. I didn't get to other types of functions, like other types of problems. So this one says identify the statement as an expression or as an equation, then simplify the expression or solve the equation. So again, equations already have an equal sign, right? So this first one here is an equation. And now let's solve this equation. So how do we solve it? Well, we got 0 on one side. The other side is already factored. We can just set each factor equal to 0. So 2c plus 1 equals 0. And 4c minus 9 equals 0. So here we get c is negative half and c is 9/4. Okay, so those would be our two solutions. Whereas this one here is an expression, right? There's no equation. There's no equal sign. So it's an expression. And so how do we simplify this? We could just multiply this out or FOIL it out, right? And so simplified version would be 8c squared minus 18c plus 4c minus 9, or 8c squared minus 14c minus 9. So here, same thing, right? So this first one is an expression because there's no equal sign, so it's an expression. And then how do we simplify it? Since it is an expression, we just multiply it out, right? So that would give us 4z squared minus 18z minus another 18z, and then plus 81 plus 12. So the simplified version would be 4z squared minus 36z plus 93. Whereas this one here is an equation, right? So to solve this equation, what we could do is just, well, if I got 2, so it's an equation. Now let's solve it down here. So 2z minus 9 squared equals 12. We can take the square root of both sides. Don't forget that plus or minus, right? So 2z minus 9 equals plus or minus the square root of 12, which is 2 square roots of 3. And then now we get z by itself, adding 9. So 2z equals 9 plus or minus 2 root 3. And then dividing by 2, we get z equals 9 plus or minus 2 root all over 2. Okay. Same thing here. So both of these are equations, right? Both of these are equations because there's already an equal sign. So how we solve them, we can try factoring. Okay, so it's an equation. I'll solve it. Y squared minus 9y minus 20 equals 0. So try factoring, right? How we try factoring? We got 0 on one side. There's 3 terms on the left side with 1 in front. So double bubble, y and y. But now we need numbers that multiply to give me negative 20 combined to give me negative 9, right? So let's say 1 and 20. 2 and 10, 4 and 5. Those are our only options, right? So if I put 4 and 5, we'd have to put negative 4 and positive 5. That doesn't really work, right? Because it gives me negative 20, but doesn't give me negative 9. Or even try to apply negative 5 and positive 4. Neither one of those works. And so this actually doesn't factor. It's not factorable. So instead, we have this quadratic formula, right? So that's 9 plus or minus the square root of negative 9 squared minus 4 times 1 times negative 20 all over 2 times 1. That's 9 plus or minus root. That's 81 plus 80, which is 161 over 2. And it doesn't simplify any further than that. Okay, whereas the second one's also an equation, but to solve it, I think this one does factor, right? So double bubble, y and y, and I think negative 5 and negative 4 works because that gives me positive 20 when I multiply it, right? And so setting each factor equals 0, we get y equals 5 and 4. Those would be the 2 solutions. All right, same thing here. Both of these are equations, but to solve them, we have to simplify things, right? So here, if I distribute the 4, we get 4m minus 32 equals negative 7 minus 3m. But now it's a linear equation. So to solve it, add 3m, 7m. Add 32, we get equals 25. And divide by 7. So m is 25 over 7. This was also an equation, but if I distribute, we get 4m squared minus 32m equals negative 7 minus 3m. And now this is a quadratic. So to solve a quadratic, get 0 on one side by adding 3m and add 7. So 4m squared minus 29m plus 7 equals 0. And now we can try factoring or use the quadratic formula. Right here, I think it does factor because the AC method would say 4 times 7 is 28. So what numbers multiply give me 28, combine give me negative 29, negative 28, and negative 1. If I rewrite that middle term, so 4m squared minus 28m minus m plus 7 equals 0. And now we factor by grouping, right? Group these two. What's their GCF? 4m. We're left with m minus 7. Group these two, their GCF is negative 1, and we're left with m minus 7. And now they both have an m minus 7. So m minus 7 times 4m minus 1. So the 0 one side factor the other side. Now set each one equal to 0. We get m is 7. By solving this equation, again, it's a linear equation. So distributing, we get negative 7z plus 35 minus 3 equals 40 minus z plus 4. Combining like terms, we get negative 7z plus 32 equals 44 minus z. Adding 7z to both sides and then subtracting 44, we get negative 12 equals 6z. So z equals negative 2. All right, same thing here, we distribute, right? So we get 10y plus 2 equals 8y plus 8 times y plus 6. Distributing again, we get 10y plus 2 equals 8y plus 8y plus 48. Combining like terms, 10y plus 2 equals 16y plus 48. Subtracting 10y, we get 6y on this side. Subtracting 48, we get negative 46. And then dividing by 6, we get y is negative 23 over 2 over 3. All right, here it involves fractions, so we want to multiply by the LCD. Here the LCD is 21, right? So multiply everything by 21 first. Including this one, multiply by 21, right? So what happens is that allows us to cancel the denominators. We get 3p minus 9 plus 7p equals 3p minus 6 plus 126. Now combining like terms, we get 10p minus 9 equals 3p plus 120. Subtracting 3p, we get 7p. Adding 9, we get 129. And then dividing by 7, we get p is 129 over 7. All right, so this is solved by using the quadratic formula. Okay, so first we have to formula this out, right, by, this gives us 21p squared minus 35p plus 18p minus 30 equals, distributing here, we get negative 14p squared minus 30p minus 18. Then combining like terms, we get 21p squared minus 17p minus 30 equals negative 14p squared minus 30p minus 18. Bring it all to one side because it's quadratic. That'd be adding 14p squared, we get 35p squared. Adding 30p, we get plus 13. Adding 18, we get minus 12 equals 0. And now use quadratic formula. So that's p equals negative 13 plus or minus the square root of 13 squared minus 4 times 35 times negative 12 all over 2 times 35. So that's negative 13 plus or minus 43 over 70. So we'll split it up in two separate cases, right? Negative 13 plus 43 over 70 and negative 13 minus 43 over 70. Now we simplify those. So negative 13 plus 43 is 30 over 70, so 3/7. And here negative 13 minus 43 is negative 56 over 70. Dividing both by 7, we get negative 8 over 10 or negative 3/5. Sorry, negative 4/5. Okay, this one here says all about using the quadratic formula, same thing, but let's get rid of the fractions first, right? So multiply everything by 8, helps us out a bit. We get 4w squared minus 4 equals 3w. Subtracting 3w, we get 4w squared minus 3w minus 4 equals 0. And now use quadratic formula. So 3 plus or minus the square root of 9 minus 4 times negative 4 all over 8. So 3 plus or minus the square root of 73 over 8. This one says solve by using any method. So let's first FOIL this out, right? Before we get 4x squared plus 8x plus 18x. 4x squared plus 8x plus 9x plus 18 equals 4x squared plus 154. But notice it's a quadratic, kind of, except the 4x squareds go away on both sides, right? So we end up with just 17x plus 18 equals 154. Subtracting 18, we get 17x equals 136. Dividing by 17x equals 136 over 17, which is just 8. All right, this one here says make an appropriate substitution in this solve. So like here, we'd say, well, let u equal 9x minus 2. This becomes u squared minus 4u minus 117 equals 0. Now, it's a quadratic equation. We can solve with the quadratic formula, or I'll try double bubble, u and u. And then what numbers? Let's see. 1 and 117, 3 and 39. Let's see. 9 and 13. I think that works. So minus 13 plus 9. And so u would equal 13 and negative 9. Or in other words, 9x minus 2 equals 13. And 9x minus 2 equals negative 9. So solving these separately, adding 2, we get 9x equals 15. And so x equals 15 over 9. We're dividing each by 3, we get 5/3. Here, adding 2, we get 9x equals negative 7. And so x equals negative 7/9. So those will be our two solutions. Here, we're doing another substitution, right? Let u equal n plus 7 over 3. Then this becomes 16u squared minus 40u plus 25 equals 0. Notice this is, if we see that something squared in the first term and something squared in the second term, sometimes this is a binomial squared, right? We check to see, okay, this is 4u squared. This is 5 squared. If I multiply these, we get 20u. Doubled, we get negative 4. We get 40u, but it's a negative, right? So really, we'd say that's 4u minus 5 squared, okay? Or we could just use the AC method that equals 0. So solving square root on both sides, don't forget the plus or minus. We get 4u minus 5 equals plus or minus 0 is just 0. So u equals 5/4. So if u equals 5/4, then 5/4 equals n plus 7 over 3. And so now we're solving for n, right? By multiplying by 3, so we get 15/4 equals n plus 7. Subtracting 7, we get n equals negative 13. Okay, this says solve the equation. Write your answers in exact form, simplified form. So here we got x cubed plus 4x squared equals, if I distribute, we get 49x plus 196. Getting 0 on one side, we get x cubed plus 4x squared minus 49x minus 196 equals 0. And now we're trifactoring by grouping, right? So if I group these two, their GCF is x squared. That leaves me with x plus 4. If I group these two, their GCF is negative 49. That leaves me with x plus 4, which we kind of should have seen coming. And so now That would give us x plus 4 times x squared minus 49. Again, this can factor further because it's a difference of squares, right? So x plus 4 times x plus 7 times x minus 7 equals 0. And so our solutions, setting each of those equal to 0, we get -4, -7, and 7. All right, here we multiply by the LCD, so multiply by 5x. All right, so that gives us x plus 2 plus 5x equals 5 times x plus 9, so 5x plus 45. Combining like terms, we get 6x plus 2 equals 5x plus 45. And then subtracting 5x, we get x. Subtracting 2, we get equals 43. Now, with these rational equations, we definitely want to check our answer, meaning we're checking to plug it back in to the denominators, make sure we're not dividing by 0. So here, I know x cannot be 0 from these denominators. I didn't get 0, so we say the solution is a finite set. All right, so similarly here, right, I multiply by the LCD, but the LCD here is just x minus 5 times x plus 4, which is x squared minus x minus 20. So, multiply everything by x minus 5 times x plus 4. X minus 5 times x plus 4. And this one as well, x minus 5 times x plus 4. Well, here, that is this denominator, so we just get -9 equals. Here, the x minus 5's cancel, so we get minus 5 times x plus 4. And then here, the x plus 4 is canceled, so we get equals x minus 5. I don't know where those extra equals came from. So now, distributing, we get -9 minus 5x minus 20 equals x minus 5. Subtracting, or combining like terms, we get -5x minus 29 equals x minus 5. Then we can subtract x, we get -6x. Add 29, we get 24. And then dividing by -6, we get x equals -4. That'd be our only potential solution. But I'm saying potential because remember, if I plug it back in, that would be me dividing by 0 here. So since this is our only potential solution and that one didn't work, there is no solution. Okay, so we'd say the solution set is the empty set this time. All right, so this one here, we have to find the common denominator, right, by factoring each denominator. So here, we factor by double bubble. This is x minus 9 and x plus 7. Here, we factor, we get x minus 9 times x plus 9, difference of squares. And here, we would get, this is x plus 9 times x plus 7. So our LCD would be, okay, I need an x minus 9. I need an x plus 7. And I need an x plus 9. So that'd be the whole LCD. So multiplying each of these fractions by that LCD, stuff cancels, right? Now I'm not going to write it out. It's going to be a lot to write out. But notice this one has the x minus 9, x plus 7. It's missing the x plus 9. So I'm going to multiply the numerator times x plus 9. 5 times x plus 9. Here, same thing. It has the x minus 9, x plus 9. It's missing the x plus 7. And so I'll multiply the numerator. This -1 times x plus 7. And here, same thing. It's missing the x plus 9. It has the x plus 9, x plus 7. It's missing the x minus 9. So I'll multiply its numerator times x minus 9. Distributing, we get 5x plus 45 minus x minus 7 equals 5x minus 45. Actually, these 5x's cancels on both sides. So we get, combining like terms, we get, what's this? 38 minus x equals -45. Subtracting 38, we get -x equals -83. So x equals 83. Again, we want to check it. Again, we want to check it by plugging it back in and making sure we don't violate any of the denominators. But the denominators, we just know x cannot be 9, -7, or -9. I didn't get those, so we're good. This one says graph this function, fx equals 3 to the x. Again, we have a horizontal, we did some graphing earlier with these exponentials, right? We have a horizontal asymptote, I'll just do it here. We have a horizontal asymptote at y equals 0. It goes to the point 0, 1, and it makes this shape, okay? And we did the domain and range already for those types. Domain would be our real numbers, the range would be from 0 to infinity. And similarly here, except now it's a decreasing function because the base is smaller than 1, but there's no shifts or anything, so it's similar. This one here says graph this function. Now the log functions we did earlier as well, right? We did the ln function. There's no shifts or anything, so this one just has a vertical asymptote at x equals 0. It goes to the point 1, 0, and it makes this shape here, okay? Because that base is bigger than 1. And how we want to graph these on Alex is, it says plot 4 points. We want to base our points that we're plugging in based on this base. So if I plug in 2, right, log base 2 of 2 is just 1. If I plug in 4, log base 2 of 4 is 2. If I plug in half, log base 2 of half is -1. I plug in 1/4. Log base 2 of 1/4 is -2. So you want to plug those numbers in, okay, based on the base. And then similarly here, okay, except this one's going to be a decreasing function. All right, then we have to solve equations that involve exponentials. Like here, we try matching the bases, right? So here, okay, this is 4, which is base 2. 2 squared to the 2x minus 6 equals, this 8 is 2 cubed, so 2 cubed to the x minus 2. And now we can multiply those powers. So we get 2 to the 4x minus 12 equals 2 to the 3x minus 6. And now the bases go away. So we get 4x minus 12 equals 3x minus 6. Subtracting 3x, we get x. Adding 12, we get equals 6. So That'd be our solution. Now this one here says solve this equation, but this is exponential, but we can't match the bases. And so we still subtract 2, so we get 1095 equals 11 to the x. But now we have to ln both sides, right? So ln of 1095 equals the ln of 11 to the x. And why are we doing that? So I can bring that power, it can mosey on down in front, right? So ln of 1095 equals x ln of 11. Now dividing by ln of 11, we get x is ln of 1095 divided by the ln of 11. We use our calculator to approximate this value. So 34, we do a similar thing here, right? We have to first isolate the exponential. So subtract 3,500. So 10 to the 4 plus 3x equals 1,500. I'm sorry, 100,500. Then ln both sides. So that would give us the ln of 10 to the 4 plus 3x. We could ln both sides, or we could actually log base 10 both sides. Since it's a base 10, we probably want to use log base 10. So in other words, just log both sides. So if I log 10 to the 4 plus 3x, and then take the log of 100,500, well, the log and base 10 cancel, so we get 4 plus 3x equals just log base 10 of 100,500. Now we subtract 4, so 3x equals log of 100,500 minus 4, and then divide by 3. So x would equal log of 100,500 minus 4, and then divided by 3. So for this one, it's about 2.9186, and for this one, it's about 0.3341. Okay, this one here, we use a u substitution, right? So let u be just e to the t. Then we get, this is u squared minus u minus 20 equals 0. So double bubble, u, and then this will be minus 5 and plus 4, right? So then, you know, u equals 5 and negative 4. In other words, e to the t equals 5, and e to the t equals negative 4. ln both sides, we get, this is t equals ln of 5. ln both sides here, though, we get t equals ln of negative 4. And again, we said we can have negatives as our arguments. And so we know just t equals ln of 5, which is approximately 1.6094. All right, for this one here, it's a log equation. So first, let's isolate the log, right? So subtracting 13, we get 9 log base 7 of 9 minus 8z equals 18. Dividing by 9, we get log base 7 of 9 minus 8z equals 2. And now we make our circular motion. That's 7 squared equals 9 minus 8z. In other words, 49 equals 9 minus 8z. Subtracting 9, we get 40 equals negative 8z. And then dividing by negative 8, we get z is negative 5. But just like with those rational functions, with these logarithmic functions, we have to check to make sure when I plug it back in, I don't get any negative, well, make sure my argument is still positive. If I plug in negative 5, we get 9 plus 40, which is 49. It's positive. Okay, so z is negative 5 as my solution. Right here we have nothing but logs, right? ln. Okay, so that works because now we can say, well, if I can match the bases or match the ln's on both sides, right? So here we would get, this is the ln of, to put these together, we'd say that's x times x minus 9. Multiply their insides because there's a plus in between, equals ln of 11x minus 91. Now the ln's just go away, so this becomes just x squared minus 9x equals 11x minus 91. Now it's quadratic, so get 0 on one side. Subtracting 11x, we get x squared minus 20x. Adding 91, we get plus 91 equals 0. And now we can try factoring double bubble. X and x, I think what, negative 7 and negative 13 equals 0. Now setting each factor equal to 0, we get x equals 7 and 13. But remember, we have to check to make sure when I plug it back in, I don't get any, make sure my arguments are still positive. If I plug in 7, notice what happens. That's 7 minus 9 is negative 2. So 7 doesn't work. The only one that works is 13 here, okay? Now this one's a rational equation, so multiply by, oh wait, sorry. It says solve for r, okay? So to solve for r, just get r by itself. Again, I will still multiply by the LCD. Multiply everything by 4 first, okay? Just get rid of the fractions. It just helps. So that gives me 5w plus, this becomes 2 times 3 times r, 6r equals 4. Getting r by itself, subtract 5w, so 6r equals 4 minus 5w. And then divided by 6, we get r is 4 minus 5w over 6. Now here we're solving for x, again, x by itself, right? So just subtract tw. So we got to get all the x stuff together first. So if I subtract tw, after I subtract qx, get the x stuff to one side. So this becomes 5x minus qx equals 7 minus tw. And now I can factor out an x, right? So x times 5 minus q equals 7 minus tw. Dividing now, we get x is 7 minus tw over 5 minus q. Here to solve for a, we first multiply by the LCD, which is abz. So multiply everything by abz, and stuff gets to canceling. Like here, the a's cancel, so it gives me just bz times 1. Here, the b's cancel, so it gives me az times 1. And here, the z's cancel, so it gives me minus ab. Now I'm solving for a, so factoring out of a, we get bz equals a times z minus b. And now dividing, we get bz divided by z minus b is a. Here, solving this one for a, again, the a's is already together in one spot, so we just subtract. We get a squared equals d squared minus b squared equals d squared minus b squared minus c squared, and then taking the square root. Don't forget the plus or minus, right? So a would equal plus or minus the square root of d squared minus b squared minus c squared. It does tell me that a is positive, and so I don't have to include the plus or minus part. All right, solving this one for k, we'd say, well, it's an exponential because k is in the exponent. And so first we would divide by q0. So q over q0, this is supposed to be a q, equals e to the negative kt. And now we can ln both sides, right? And so this would be the ln of q over q0 equals, but the ln of the right-hand side is just negative kt. So if I'm solving for k, we divide by negative t. So k would just equal ln of q over q sub 0 divided by negative t. Solve the linear inequalities. So here we're solving by multiplying first by the LCD. Okay, so let's pretend it's an equal sign. That's what we're doing. So multiplying by 28 throughout. Well, 7 goes into 28 4 times. So we get 4 times 3 plus c, which is 12 plus 4c. This one is, okay, we're left with 7. So negative 7, the negative 7 times c plus 1. So negative 7c minus 7 is less than. And then here, multiplying by 28, we get just negative c. Combining like terms, we get negative 3c plus 5 is less than negative c. Adding negative c to both sides, subtracting 5, we get negative 2c is less than negative 5. But then dividing by a negative, we flip the inequality. So c is greater than 5/2. So in set builder notation, we'd say the set of all c's such that c is greater than 5/2. Interval notation, we'd say, okay, that's parentheses 5/2 to infinity, and then we know how to graph it on the number line, right? It's 2.5. So we'd say here's 2.5, put a parenthesis on it, and then shade this way, okay? Or it may say open circle, and then shade this way. All right, so we're doing something similar here, right? So negative 11 plus 4c is greater than 5c minus 15 minus c. Combining like terms, negative 11 plus 4c is greater than 4c minus 15. But then when I subtract 4c, notice what happens. The c's go away. So we get negative 11 is greater than negative 15. Is this true? Yeah, negative 11 is bigger than negative 15. So since this is true for every real number c, then this solution set is all the real numbers. So in set builder notation, we'd say that's this r here, or we'd say negative infinity to infinity. And of course, for the graph, we would graph this entire number line. This one has the x in the middle, and so we're going to just subtract 9 from all three parts. So negative 14 less than or equal to negative 5x is less than, if I subtract 9, we get negative 4. But they have to divide by negative 5, so this flips the entire inequality, right? So this becomes 14/5 is greater than or equal to x, which is greater than or equal to 4/5. Now, that's not normally how we write a number line, so really we want to write this as 4/5 is less than x. This equal sign is not there, which is less than or equal to 14/5. So except in interval notation, that would be parentheses 4/5, comma, 14/5 with a bracket. And the solution set, of course, we would graph it as just like you normally would, a shade in between those two numbers. All right, almost done. So here we're going to do a similar thing, right? Multiply everything by 4, so we get negative 4 is less than or equal to 5x minus 4, which is less than or equal to 20. Adding 4, we get 0 is less than or equal to 5x, is less than or equal to 24, and then dividing by 5, we get 0 is less than or equal to x, which is less than or equal to 24/5. Okay. So again, in interval notation, we'd say that's bracket 0 to 24/5. And of course, we graph it normally. All right, so this says, where's this function less than 0 or negative, right? So here, it's above the x-axis, and then here's where it's below, right? So where's that occurring? From negative 1 to 1. So that would be the first part, from negative 1 to 1. But then where is it less than or equal to? Well, it's equal to at negative 1 and at 1. So we'd say, oh, the rules have brackets on it, that's all. Negative 1 to 1. Here, where is it positive? Okay, it's positive from negative infinity to negative 1, and then from 1 to infinity. And where is it greater than or equal to 0? We'd say, okay, from negative infinity to negative 1, bracket, union, bracket, and then from 1 to infinity. So this says, where's this squared, m squared, less than 25? Where's that occurring? So we say treat it like an equal sign, right? So m squared equals 25. We know square root, don't forget the plus or minus, so m equals plus or minus 5. But then we say put those numbers on the number line and plug in test points, or just plug in one test point and use our multiplicities, right? So like here, if I plug in 0, is this true? Is 0 squared less than 25? It is. So it checks out, meaning all those numbers check out in between there, which means this one doesn't and this one doesn't based on our multiplicities. And so we say, okay, got it, from negative 5 to 5. It's just a strictly less than, so parentheses, negative 5 to 5 are the numbers that work. So we do something similar here, right? It's already got 0 on one side. It's already factored, so we just put those numbers on the number line. and then plug in test points, right? So we get, okay, -3, 4, and 7. And now, really, we're just plugging in one test point because all their multiplicities are 1, so we know they alternate, right? Odd opposite. So plug in 0. Let's see if it works. That's 3 times -4 times -7. Is this bigger than 0? Yeah, it is, right? This is positive something. Positive, negative, negative. It's a positive. So that one works, meaning that one checks out. So this one doesn't, and this one does. They alternate because odd opposite for the multiplicities. So the solution set, now it's a greater than or equal to. So we'd say it got it from -3 to 4, and then from 7 to infinity. And we want to put brackets on those numbers because we're included because that's the or equal to. So brackets on all. Okay. So here, same thing. We're trying to find out where this function is less than 0 or negative, right? So it's below the x-axis for this entire piece, and then from this piece on, right? So we'd say got it from -infinity all the way up to 3, and then also from 4 to infinity, from 4 to infinity. But then less than or equal to, we want to include the x-intercepts, not the asymptotes, not the asymptotes. So from -infinity to 3, but then also from 4 to infinity with a bracket on 4, include the x-intercepts, right? So x-intercept at 4. Whereas it positive, got it, it's only positive for this piece. So from 3 to 4, right? From 3 to 4. Whereas greater than or equal to, we put a bracket on the x-intercept. So from 3 to 4 with a bracket on the x-intercept, not the asymptote. So similarly here, right? Where is this function less than 0? And here's the x-axis. It's never below the x-axis. It's never negative. So it's not. Where is it less than or equal to 0? It doesn't even get to the x-axis. Okay, according to this graph. Where is it positive? Where it's positive from -infinity up until 0, and then from 0 on. So -infinity to 0, and from 0 to infinity. And where is it greater than or equal to 0? It never hits the x-axis, so it's the same thing. -infinity to 0, union 0 to infinity. Oh, I'm sorry. The asymptote is at -1 here, not at 0. I thought it was on the x-axis, on the y-axis. Sorry. So this would be -infinity to -1, and then from -1 to infinity. And same thing for this one. Okay, this one says solve this inequality, right? Again, how we solve these is by pretending, right? Pretend it's an equal sign. And so if it was, we want to find, okay, where the numerator or denominator equals 0, right? So if I factor this numerator, that's what? P plus 5, and then P minus 3. And the denominator is P plus 9. And so we're going to put all those numbers on the number line. So setting them equal to 0. So -5, and then -9, and +3. And now we plug in test points, or at least one, right? Plug in, say, 0. I'll plug in 0, this would be -15/9, which is that bigger than 0? It's not, it's negative. So that region would not work, which means, according to our multiplicities, that means this one works, and this one doesn't. And so the ones that work are from -9 to -5, and then from 3 to infinity. Now, it says greater than or equal to, so we want to put as many brackets as possible, but only for the x-intercepts, not the asymptotes. In other words, I'll put a bracket on -5 and 3. Those are the x-intercepts when the numerator equals 0. Put a parenthesis on -9. That's where the denominator equals 0. That's a vertical asymptote. All right, almost done. If function g is given, identify the parent function, then use the steps of graphing multiple. Okay, so here, this is a reciprocal function, right? And so we know this is shifted to the left 7 and down 5. And this number just kind of stretches it. Okay, so you can kind of pick out the options there. Okay, so use transformation to graph this function. So yeah, this one shifts to the right 5, it's stretched, and then down 3. Save us time, I'll let y'all do that. This one here, shifted to the left 2, it's reflected, and shifted down 4. What else? We're almost done. So here, right, the equation line that passes through -2, -4, and it's perpendicular to this line, right? So remember, perpendicular lines, we have negative reciprocal slopes, right? So first we need to find the slope of this line. Okay, so find a slope, we put it in slope intercept form. Subtracting x, we get -2y equals -x minus 5. Divided by -2, we get y equals 1/2 x plus 5/2. So the slope of this line is 1/2, meaning the slope of my line has to be negative reciprocal. So the slope of my line is -2, negative reciprocal. Then we use point slope form to get the slope intercept form, right? So y minus y1, y minus -4 equals my slope, m times x minus -2. So that's y plus 4 equals -2 times x plus 2, or y plus 4 equals -2x minus 4. Subtracting 4y equals -2x minus 8. That'd be the equation of my line. So it says write the answer in slope intercept form, which I just did, and write it in standard form, ax plus by. That just means add 2x. So the other form would be 2x plus y equals -8. 58 is similar. Okay. So finding the slope of this line. It said, but mine needs to be parallel, meaning the same slope. So finding the slope of this line, we would get 4y equals -3x minus 2. So y equals -3/4 x minus 1/2. So if their slope is -3/4, so is mine. So my slope is -3/4, and so we use point slope form. Y minus -4 equals -3/4 x minus negative 1. So y plus 4 equals negative 3/4 x minus 3/4. And then subtracting 4, we get, that's 12/4, right? So, sorry, that's 16/4. So y equals negative 3/4 x minus 19/4. And then to put it in standard form, we have to multiply by 4. So 4y equals negative 3x minus 19. So adding 3x, we get 3x plus 4y equals negative 19. All right, last two. So to find the x-intercepts of a rational function, we just have the numerator equal to 0. So the x-intercepts would be here 5/3. It's already factored in negative 7. To find the vertical asymptotes, we have the denominator equal to 0. So the vertical asymptotes would be at x equals negative 1 and x equals negative 3/2. Find the horizontal or slant asymptotes, we say look at the degrees. So if I multiply, there's x's here and here. So degrees. So if I multiply this out, let's multiply it out. We have 3x squared plus 21x minus 5x minus 35. And then here, if I multiply this out, we get 2x squared plus 3x plus 2x plus 3. So the degrees are the same, and so we would have a horizontal asymptote at y equals, dividing their coefficients 3/2. And to find the y-intercept, we just plug in 0. Okay, so plug in 0 here. Notice all this stuff will go away. So we get negative 35/3. So y equals negative 35/3 would be my y-intercept. Okay, last one. Similar thing here, right? To find the x-intercepts, we just have the numerator equals 0. So we get negative 3x minus 8 equals 0. Adding 8, negative 3x equals 8. So x equals 8/3 would be my x-intercept. Find the vertical asymptotes, we just have the denominator equals 0. So vertical asymptote here would be x squared minus 9 equals 0. Or x squared equals 9, so x equals plus or minus 3. Right, so x equals 3 and x equals negative 3 are my two vertical asymptotes. Let's find a horizontal oblique asymptote. We look at the degrees. If the degree of the numerator is bigger, then we know we have a horizontal asymptote. It's at y equals 0. And then to find the y-intercepts, we plug in 0, right? F of 0 would be a y-intercept. We get negative 8 over negative 9, so 8/9. Okay, I think that's it. Have a great day. Always remember, math is everywhere.